we're going to talk about two functions. So if you have two separate things and how to tell when they are inverses of each other. So inverses are kind of this special relationship. And basically what happens is you flip-flop your points. So if your x's become your y's and your y's become your x's, basically they just trade spaces, then those are inverses of each other. The way it looks on your graph, these will always be a reflection over the line y equals x. So always a reflection over the line y equals x. So do you see how this line right here is your y equals x? And if you reflected over that line, you would land on the other graph. So this is your line y equals x. So they're always a reflection over that line. So if you look at this part, see how it would reflect here, and then if you look at this part, it would reflect up here. I'm not going to do this, actually, so we're going to move on to the next one and do like a full example together, I think. Okay, here's where I'm going to start using some different colors. It says that we want to first graph. Okay, so I'm going to start by graphing. I'm going to pick one of my two colors and I'm going to graph. And I'm going to graph what they give me. Okay, so I'm going to graph a point over 0 up at 2. I'm going to graph a point over 1 up at 5. 1, 2, 3, 4, 5. I'm going to graph a point over 5. 1, 2, 3, 4, 5 up at 6. 1, 2, 3, 4, 5, 6. And then I'm going to graph a point over 8 up at 9. So I'm over 1, 2, 3, 4, 5, 6, 7, 8 up at 9. 1, 2, 4, 5, 6, 7, 8, 9. All right, and I'm going to get a straight edge to connect these. If you are a little type A like I am and you like things to look nice, I'm going to connect these with my ruler. So they want us to look at this diagram that's created. If you're not bothered, go ahead and just draw it in freehand. But you guys already know who I am as a person, so you know I'm going to use this. All right. To find the inverse, it's super easy. I'm not even going to do a calculation. I'm going to set up my table even the exact same way so that they're oriented the same way. So this is going to be my inverse down here. All you do is take your x and y, flip them. This was 0, 2. Now I'm going to write 2, 0. Now I'm going to write 5, 1. What am I going to put for my next point? What goes on top? Yeah, 6, 5. And the next one? 9, 8. Okay, so now let's graph those. I'm over 2, I'm up 0. I'm over 5, 1, 2, 3, 4, 5. I'm up at 1. I'm over 6, and I'm up at 5. 1, 2, 3, 4, 5. I'm over 9, and I'm up at 8. So I'm over 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw those in. So I'm going to draw my lines in the same way I did with the blue graph. And this one's almost a little bit easier to see than the other one. Let me draw in the line y equals x as well. So the line y equals x goes right through the origin like this. So this is my line y equals x.
So you did lie about the colors.
I did lie about the color. Well, you could use like a pencil for that one. Do you agree that it looks like a reflection over the line y equals x? If I took the blue graph and flipped it, would it land on the, what would we call that? Mauve? Would it land on the mauve graph? Yes, no? Okay, so I'm going to write basically what we learned here. Our x and y values flip. X and y values flip. I think that would be beneficial to have as a note to yourself. If your x and y values flip, what's going to happen to your domain and range? Yes. Domain and range also flip. Because remember, your domain is x and your range is y. So if x and y flip, your domain and range are also going to flip-flop. So both of those, I think, are worth writing down. Not too shabby, right, for starters? I think this is an okay lesson to kind of squeeze in. I don't think this is a bad one. Okay. The other thing that I want to show you, yep, there's only one other page. The other thing I want to show you is how to find the inverse of an equation. So we did ordered pairs, right? Now we want to find the inverse of an equation. There are two steps. Step 1 is to flip x and y. Step 2 is to solve for new y. The reason I call it new y is because a minute ago it was x. So I call it new y. So let's take a look. Look at part A. Do you see a y? Okay. If you squint a little bit and you think about what you know f of x is, yeah. So let's rewrite this. Y equals 3x minus 8. So remember, f of x is a fancy function notation way of saying y. All right, so now we're going to flip x and y. Step 1, flip them. So literally they're switching spots. And now I'm going to solve for new y. This is new y. Because a minute ago it was x, right? So that's why I call it new y. We want to get y alone. How can I get rid of the minus 8? Add 8 to the other side. It's always best to get rid of whatever's added or subtracted first, because otherwise we're going to end up with some fractions. X plus 8 equals 3y. Again, I'm still trying to solve for my friend new y. How can I finish getting y by itself? Divide by 3. Now, here's the good news. You can leave your answer just like this. But we're going to be fancy pants, and we're going to write it in a fancy way. Are you ready? F to the negative 1 of x equals, my answer was x plus 8 over 3. So this funny notation here means, hey, this thing is the inverse with this thing. So this notation here with the negative 1 means they're inverses. That's the relationship that they have with each other. Okay, look at B. If we squint, is there a y in there? Yeah. So let's do that first. What's my next step? Before that even. Switch the x and the y. Yep. And honestly, you could have done that later and it'd be okay, but I like to switch first every time so I make sure it happens. Okay, now I heard multiply by 3. Do we agree with that? Because it helps us get rid of the fraction? Yep, I love that idea. So again, we're solving for new y, which means we're trying to get this alone. So we're getting rid of the most problematic part first, which is to divide by 3. So 3x equals 4y minus 5. All right, we're still trying to get this friend alone. How could we get rid of the minus 5? Add it. Yep, remember law of opposites. We'll do the opposite thing to make it go away. So this cancels, set equal to 4y. Then what? Yeah, divide by 4. Now, once I divide by 4, I'm done. So I can write my final answer, f to the negative 1 of x, again we're being fancy, equals 3x plus 5 over 4. Now, I know those numbers don't reduce, but let's just pretend for a minute. Let's use our imagination. Let's pretend this isn't a 3, let's pretend it's a 2. And let's pretend this is an 8. Could I go through and simplify, dividing everything by 2? Yeah. So if you can simplify, you should. It's not going to happen often, but it will happen sometimes. All right, let's look at part C. And actually, this one I would do a step before I would switch. Let's distribute the 3. So I'm going to rewrite it. Y equals 3x minus 7. Then what? Nope. Oh, yes. No, we don't. Just, yes. Yes, we do. That's, yes. I've got nothing. All right. Now what do you need to do? Now that we've actually distributed. X equals 3y minus 21. Okay? And then let's solve for new y. So what would you do first? Add 21. So x plus 21 equals 3y. Then what? Divide by 3. So y equals x plus 21 over 3. And then we write our fancy notation. F to the negative 1 of x equals x plus 21 over 3. I think I've got about 5 minutes left, so I think we can maybe sneak this problem in. All right, last one. We want to graph. If you're just coming in, I'm going to do the song and dance again. So you're going to get the second showing. So don't worry right now, just come in and sit down. All right, let's graph this one as it is. I'm going to graph using the idea that this is in slope-intercept form. So my intercept is at negative 1, 2, 3, 4, 5. And my slope tells me to do what? Yeah, down 1 over 2, down 1 over 2. So that would be one of my graphs. If you're just coming in, I'm going to do the whole song and dance again, so do nothing. Just join us. Yeah, there's actually no song or dance, though. You'll be disappointed. Yeah. Okay, now let's find the inverse. Are you ready? This is y. So I'm going to switch. X equals negative 1/2 y minus 5. I want to solve for new y. How can I get my y alone? What would you do first? Add 5. X plus 5 equals negative 1/2 y. How can I get rid of the negative 1/2? Let's get rid of it in one step. We could divide. Could I also multiply it, though, by negative 2? Yeah, that works a little bit better, I think. So we're going to multiply by negative 2. And this time I'm going to distribute it to both numbers. I know. Watch out. Negative 2x minus 10 equals y. So if I rewrite it in my fancy notation, because we want to be fancy, right? Oops. I need negative 2x minus 10. So now I'm going to graph this one. So I'm going to start with my intercept, which is at negative 10. So negative 5, 6, 7, 8, 9. So negative 10 would be here-ish. Going down 2 over 1 is going to be a little obnoxious. So let's go up 2 over 1 and go the other way. So instead of going down 2 over 1, I'm going to go up 2 over 1, up 2 over 1. So this is my inverse graph. Huh? Sure will. Okay. So you do have homework tonight. It's not a lot. I'll tell you what it is though, so you can write it down. So people who got the first show, page for homework 311, numbers 1 to 2, 5 to 12, and 27 to 28. And we're going to check in this assignment as well as the worksheet that was due today. We did not check that in because we don't have probably time. Good? Okay. Sophomore friends, I'm going to wait till they get called down and then